Greetings, friends. My name is John Gabriel, and today I'm going to be showing you how humans realize the concept of time. I know I've had some previous videos on this, but I've actually simplified things a lot, and I want to share these ideas with you once again in a very simple and easy way to understand. So, let's begin. Now, a long time ago, a few years ago, I wrote a LinkedIn article. By the way, I'm no longer on LinkedIn. I have been banned. And you can only guess what the reason is there. My ideas are not liked. And more than my ideas not being liked, I am not liked and I'm censored. So, out of the blue, I just found out a few days ago that my account had been restricted, and I have approached them several times. Even Jeff Wiener, I've sent him a message on Twitter to have my articles downloaded or let me download them, but I've heard nothing so far. Just goes to show you what kind of people I'm dealing with. In any case, I was never on LinkedIn to find a job, only to share my ideas, and I guess they didn't like my ideas, and more importantly, they didn't like me. But in any case, so this is the old article to which I'll place a link in the details section, and I won't waste any more time. I want to show you how we discovered or realized the concept of time, right? So right from the beginning, I'm not going to assume anything as fact or anything as previously established. So this video is about what is time exactly and how it was realized. So to well define the concept of time, we need two things. Okay, we need the existence of matter and an event that is described by constant and repeatable motion. Notice that it's not enough to have just either one of these requirements. You need both. Okay, so if you have no matter, you have no time. If you have no events or no motion, which is repeatable or constant, you cannot have time. So those are the most important definitions or requirements that are needed to well define the concept of time. And of course, time cannot exist in an empty universe. I know a lot of you have heard many stories about space-time and, dilation of time and all that. That's nonsense. If you read my article, you'll see that time dilation has nothing to do with special relativity, but is a fact that there is no such thing as constant motion. Anyway, or all we have is almost constant motion, but nothing exactly constant. So our first clue is to identify an event, right? And one that is familiar to us. So for example, we're not going to choose the motion of some other planet or some other event that we can't relate to. We're going to choose an Earth day, which is more or less constant and repeatable. But wait, if we do not first define day, all right, what is day? Because day is time. Then our definition of time will be circular or self-referential, and such definitions are obviously nonsense. So we have to require constant and repeatable events, and we anticipate that any time unit must be indicated by an event that repeats at regular or constant intervals. So we know a day is more or less the time from one sunset to another sunset, or one sunrise to another sunrise, or one evening to another evening. So we can say that we can realize from this that our 24-hour time comes from the Egyptian shadow clock, and it should come as no surprise the time units were marked on a circular device, because it is possible to mark out evenly spaced arcs with only a compass. Did you get that? So here you can see where the geometry comes in, right? And why they used 24-hour time. So Had the Egyptians chosen different calibrations of their shadow dial, we could easily have had a different number of hours in a given day. So everything comes from the concepts of sound Greek geometry. Everything, without exception, everything we know. And of course, that comes from the first realization of philosophy, okay? Because philosophy is the king of knowledge and mathematics is the queen of all sciences. So there are no postulates or axioms in geometry, and I have an article also in the details section where you can read that. But back to the article. Why was the circle chosen to calibrate clocks? The answer is simple. The circle is the third requirement, not the axiom of Euclid's elements, because there are no axioms, which is the first geometric object that explains or describes symmetry, okay? That's the Greek word meaning same measure. The previous two requirements concern the shortest distance, the straight line, and its extension or making it smaller. So, now we know how we arrived at 24-hour time. The Egyptians calibrated the shadow dial with 24-hour time. So this obviously affected how each hour unit would be divided. It should also become clear now why each period of time, such as a day, must be an even number and a multiple of the finest chosen granularity, okay? So they chose 360 degrees for a circle, but it didn't have to be 360 degrees. All it had to be is some even number because of the symmetry of the circle, okay? So if you're going to mark out a clock device, you want to be able to mark it up into equal partitions on either side. But we are still far from done. We still have to decide how the time units relate to the motion of the Earth. All we know for now is that one Earth day corresponds to approximately one rotation of the Earth on its own axis, and even this knowledge was not realized for several hundred years. Okay, and before that, accurate measurements were made using geometry and physics. So our next task is to relate time units directly to distance traveled. This is where the question, how long does it take, comes from. Long can only relate to distance. So a time unit is the name that is given to a distance traveled or a change of position, right? Because I mean, when you travel a distance, you're obviously changing position. So it always goes back to those 5 requirements of Euclid, okay? In a more change of position in more primitive geometric terms. And that describes the motion of a certain body, in this case, the Earth, okay? Or matter, physical matter, from one position to another. So the motion of a body must be an event that is described by constant and repeatable motion. So for this, we need to know what is speed. But we cannot use speed because it requires time. That would be circular, right? So we have a dilemma. And the problem is easily solved after we realize what is the distance of the Earth's equator, because then we know that a basic time unit, which is an Earth day, corresponds to one rotation. Voila! The speed of the Earth is one rotation per day. Okay, so that's our first primitive definition. And now what remains is relatively straightforward. We can calibrate our subtime units such as hours, minutes, and seconds by dividing the day distance into equal parts or distances. At first, each of these distances corresponds to 1 hour, and then further subdivision results in equal distances. Further subdivision into equal distances results in minutes and seconds. So we arrive at the conclusion that a time unit of 1 second corresponds to approximately 460 meters, right? And of course, we chose the meter distance much later. Rather than express speed as distance traveled over the unit distance, we rename the unit distance of 460 meters as a second, and our formula becomes distance traveled over elapsed time units. And this is exactly what is time, okay? Nothing else. None of the Einsteinian garbage or Hawking's theoretical nonsense about black holes and whatnot. Hundreds of years after the Greeks and Egyptians, physicists determined the time unit of a second more accurately, but never exactly. So they determined it at this figure here, which is almost 9.2 billion cycles of radiation in cesium atoms. And so atomic clocks were built. But all the information was realized from the Earth and its more or less constant motion. This is exactly what is time and how it was realized. So just to let you know that most physicists of today do not understand the concept of time. They have all these vague ideas about time being immortal and time existing without matter and before the universe. But that's totally illogical because time requires both the physical universe and motion. So if you just had the physical universe and no motion, you still couldn't define time. You'd need to have an event. And the event is generally defined in terms of motion from one position to the other, as in a place on Earth moving a certain distance to act as the fundamental time distance that is used, okay, which is, as I mentioned earlier, approximately 460 meters. So that's pretty much it. I offer you my free book, by the way. Now notice calculus textbooks usually are pretty expensive. They range in, they go for in the range of about $150 to $300. I'm giving you the most important mathematics book free. You will learn more mathematics and understand more mathematics than you have in all your school years. The new calculus is the first rigorous formulation in human history. And from it, I derived a second formulation which acts like your mainstream calculus and is actually 100% rigorous, unlike your bogus formulation which was inherited from Newton, Leibniz, Cauchy, and all the other idiots who came before me. So I ask you to spread this news, to spread the knowledge of my channel, to subscribe, and hopefully when I'm feeling good again and able, I will produce more videos, not only on mathematics but also on physics, which is something I love to but have not studied to the extent I have studied calculus and mathematics. Now, the thing about the new calculus is that it's easy to learn, it has no ill-formed concepts, and it can be learned by a graduate of high school mathematics without doing any further mathematics courses. Imagine being able to calculate volumes and surfaces and tangent lines and tangent planes, etc., without having to learn all the garbage you learn in a mainstream course of calculus and never quite get to master. So that's pretty much it. I hope you've enjoyed this presentation on how we realize the concept of time. Excuse me, and hope to speak with you again soon. In the meantime, stay safe and take care. Till next time, I'm John Gabriel, and this is the New Calculus channel. Goodbye.